everyone, and welcome back to another Dynamics, Physics, and the Flesh episode, this time on Newton's third law. Three blocks on a frictionless horizontal surface are in contact with each other, as shown below. A force F is applied to block A, mass ma. Part A, draw a free body diagram for each block. B, determine the acceleration of the system in terms of ma, mb, and mc. Part C, determine the net force on each block. And D, determine the force of contact that each block exerts on its neighbor. So this is the type of problem that a lot of people fear in physics because there's no numbers. You're just dealing with variables. So the answer looks messy when you get to it, but it's not as clean as a number, yet it's the proper way to solve a physics problem. Generally speaking, you shouldn't plug numbers in until the very end anyways, until all your variables have been simplified. So we're going to go ahead and just solve this problem, no numbers. So for this, and we've actually been given a diagram. Okay, so you've got three blocks on a table. Each one is given the same mass. Okay, so it's probably heavier stuff in the smaller boxes. MA, MB, MC. Force F gets applied to box MA. Okay, so for part A, we are asked to draw a free body diagram for each block. Okay, so I'm going to start off with block A. So I'm just going to draw a box and put an A inside. Simple as that. Okay, so because the block has mass for the box, okay, it's going to have a force of gravity. Now I'm going to label that FGA because it's the weight due to A. Now that weight acts on the table. Table pushes back up due to Newton's third law, and that push back up force is called the normal force. Okay, so FNA. So we got that force going up. Now F is acting on A. In order for you to draw force on a free body diagram, the force has to act on that object. And because the force F is only in contact with A, we cannot draw F for free body diagrams of B and C, only A. Okay, so F's going to the right, so I'm going to draw that in now. Now, because F is pushing A to the right, B is going to push back on A with equal magnitude, opposite direction force. So we're going to call that FB on A. Okay, so that goes in the backward direction, FB on A. It's similar to how the normal force counteracts gravity. You've got Newton's third law in action here, FB on A counteracting F. Okay, so that's for box A. Now for box B, let's draw that one down here. For box B, similar first steps. You've got weight, so you have to draw your force of gravity, FGB. And again, the table's counteracting the weight of box B, so you draw your normal force, FNB. Now also for box B, you've got A pushing on it towards the right. So we're going to call this force A on B. Now while A is pushing on B, B in turn pushes on C. So due to Newton's third law, C is actually going to push back on B with another force. So we're going to call that FC on B. Okay, so we've got our four forces now for box B. One last piece to go for C. I'm going to do that right here. Same game. FGC, FNC. Now with C, vertical forces, same idea. Horizontal forces, though, you've only got a force in the right direction. Due to F, which pushes A, pushes B, that pushes C. So we've got a force going to the right, FB on C. But there's no force going to the left here because there's nothing else next to C. There's nothing pushing left on it. That's it. Okay, so for C, that's it. So for part A, you've got the free body diagrams for A, B, and C. Okay, so that concludes part A. Now, next, we're going to look at part B, which is determine the acceleration of the system in terms of MA, MB, and MC. Now, this may seem like a daunting task at first, but it's really quite simple. It all comes back to Newton's second law. Okay, so for part B, let's keep going. We're doing Newton's second law, but think of it like this, okay? All of these boxes are moving together, okay, at the same rate because for more or less they're attached. And you've got that force F pushing on it. And yet, we've got all these other forces going on, right? So for Newton's second law, technically we have to incorporate all of them. Now, let's just get this out of the way. In the vertical direction, the boxes are not accelerating up or down. Okay, so all these forces, normal force on A, weight of A, these two balance out, these two balance out, these two also balance out. right? Because the boxes aren't going up and down. They're just getting pushed towards the right. So in the y direction, we can ignore it. We can say f net y is 0. Okay, so in the y direction, we say f net y is 0. So generally speaking, the magnitude of fn equals the magnitude of fg. So we're dealing with the horizontal direction. Now before you say, wow, that's a lot of forces, look, we've got 1, 2, 3, 4, 5 forces. Remember that Newton's third law is an action-reaction force. And according to Newton's third law, if object 1 exerts a force on object 2, the same magnitude, opposite direction force is applied from 2 onto 1. Okay, that's what the negative sign implies. Negative means opposite direction. Okay, but the magnitudes are the same. Okay, so now take a look at this. We've got FB on A, we've got FA on B. Those two are going to cancel. Look, FC on B, FB on C. These two are also going to cancel. So if these two cancel and these two cancel, you're only left with one force, F. Okay, so in reality, in the x or the horizontal direction, we haven't formally stated it as x and y, but just go with it here. Okay, in the x direction, F net x is equal to F. Okay, because all the forces cancel out. So since all other forces cancel out. Okay, so we've got our net force in the horizontal direction. Okay, so we need to get acceleration. That's what we're tasked with finding. And according to Newton's second law, F net equals ma, right? Okay, the only difference is we're working in the x direction. You don't really need to write the subscripts since we already know we're not working in the y, but let's just keep it consistent. Okay, so we're solving for acceleration. So to do that, divide both sides by mass. So F net x over mass. Now, mass of what? Well, mass of everything that's accelerating due to the force, right? So going back to your diagram, the mass is going to be the mass of the system. So collectively, mass A plus mass B plus mass C. Okay, and F net x, we just said was F. So we replace that with F and replace M with MA plus MB plus MC. So there is your acceleration for part B. So guys, I'm going to cut the video off here because parts C and D are quite long in themselves. Okay, but I hope you guys understood parts A and B. Stay tuned for video 65, Newton's third law part 2, to catch parts C and D, which will be posted the next day at 12 noon, as I post all my videos at 12 noon every weekday, Monday to Friday. Hey guys, it's been a pleasure going through this problem with you. I hope you stay tuned for the next video and enjoy the rest of your day.